have triangle ABC, and C is a right angle. The only time you have to do like laws of sines or cosines is if it's not a right triangle. So the majority of your questions will be right triangles. Angle A is 43 degrees. Side C, that's across from angle C, is 80 centimeters. Find B, that's across from angle B. So from my 43 degrees, my 80 is my hypotenuse, and B is the adjacent. What trig function involves adjacent and hypotenuse? So it's just the cosine of 43 degrees equals adjacent, which is B, over hypotenuse, which is 80. Multiply over the 80, make sure you're in degree mode. Put it in the calculator, and you get B to be 58.5083. It said significant digits. 80 is only one significant digit, so you could round this to 60 degrees.
So,
or sorry, centimeters. We weren't in degrees.
I did the law of sines.
You can. You just don't have to if you have a right triangle.
I have the same answer.
Yep, law of sines will work. There's a faster way if it's a right triangle, but it certainly works.
I used secant.
Oh. Which you could do, but it would be 80 over B, so then you have to multiply by the B and divide by the secant, but then to put it in the calculator you have to change secant back into cosine, which...
Yeah, because I got like a square root.
Yeah. Alright, is number 3 okay? So number 4, we have to find angle A. We have 2 right triangles. This is one of them, but all I know is one side. And then I have this right triangle over here where I know this is 30 degrees and this is 10. One thing we have is they share this side. So let's find that first. So if I use my triangle on the right, then from here, this is the opposite and the hypotenuse, so what trig function is that? Bless you.
Thank you.
That's
So, TOA. Opposite and hypotenuse is sine. So the sine of 30 degrees equals the opposite side x over the hypotenuse, which is 10. If it's an angle off your circle, I expect exact values. So what is the sine of 30 degrees? 1/2. So multiply by the 10. And we get that x to be 5. Now that's not my final answer. I'm just now going to use that. From A, that's opposite and hypotenuse. So the sine of angle A is 5 over 6. How do we get the A by itself?
multiply the sine.
When you move the sine to the other side, what does it become? So we do second sine, 5 over 6, and it said to the nearest whole degree, so that's just 56 degrees. Number 5. We have a person standing on top of a 13-foot sand pile. So this is 13. I'm going to form a right angle with the ground. We have the angles of depression. That goes from my horizontal down. So if you drew in the horizontal at the top, from there down, your angles are 19 and 25. We want to know how far apart the rocks are. What we're going to have to do is use these 2 triangles separately. Okay, and we can find this side in each of them, and then we could add those together to get the total distance apart. To get an angle inside the triangle, these 2 together would add up to 90. So 90 minus 19 would be 71 degrees. So in this triangle, I have my angle, x is opposite, 13 is adjacent, so that's TOA. So the tangent of 71 degrees equals x over 13. So x is just 13 times the You could certainly go ahead and plug that in if you wanted. I'm just going to wait a minute. In the other triangle, if you do 90 minus 25, you get 65. So from there, thank you, be the tangent of 65 degrees equals opposite, which is y, over adjacent, which is 13. So if you multiply that over, your y is 13 times the tangent of 65. So then to get your final answer, you just have to add those together. Plug it all in my calculator. Significant digits, there were 2 significant digits in the problem. So if I answer with 2 significant digits, it comes out to be 65.63. So that would go to 66 feet.
I just keep putting the wrong numbers in.
Any questions there? So, next one, question number 6. We have a 76-foot flagpole. Actually 76.0, so how many significant digits is that? 76.0 is 3. If there's a decimal, you count the zeros after it. Cast a shadow. Where does your shadow go? I want the angle of elevation of the sun. So your sun is up in the sky. Elevation is from a horizontal going up. So I'm just looking for that angle. So in this triangle, those are my opposite and adjacent sides. So what trig function uses opposite and adjacent? Tangent. So we'll say tangent of theta equals 76 over 57. So to move tangent to the other side, it becomes tangent inverse. So second tangent. And our angle, it said nearest, or significant digits, we had 3 in the problem. So 53.1 degrees. Questions there? Okay, number 10. Find the linear velocity. What variable is linear velocity? V. Of a point moving with uniform circular motion, if a point on the outside of the circle covers a distance of 45 miles, so distance on the outside of the circle, that's arc length, which is S, in 3 hours, so that would be the time. So using our formulas, we need a formula with V. We have V equals S over T over there on the board. So it's just 45 divided by 3, which gives us 15. S was in miles, T was in hours, so miles per hour. So I strongly recommend on those to write down what you have and what you need.
Are we getting the
Yes,
formulas?
those are on the formula sheet. Okay, number 11. Point P moves with angular velocity. Angular velocity is omega, 10 radians per second. In order to use theta or omega, they always have to be in radians. This one is, so we're good. And a circle of radius, so that's r, 3 feet. Find the distance traveled on the outside of the circle, so that's our S, in 4 minutes. So I do have an issue. This was radians per second, and this is in minutes. Those need to match. So we have to change one of them. Do you just want to change our time into seconds? 4 minutes is how many seconds? You just take it times 60. 60 seconds in a minute, so that's 240 seconds. Okay, so we need a formula with S. We can do S equals R theta, but I don't have theta. Or we can do V equals S over T, but I don't have V. So first we are going to have to use the second formula to find either the theta or the V. Which one do you guys want to find? V? Okay. So we can use V equals R omega. Our R is 3, our omega was 10, so our V is 30. So then we can do the V equals S over T. V is 30 equals S, we don't know, over, for the time we have to use the 240 seconds. So multiply over the 240. We get 7,200 feet. Is that one okay? So if you just make a list of your variables, first of all you get points just for doing that, but second of all it makes it a little more obvious where to go from there, what formulas you can use. Number 12. A lawn sprinkler is located at the corner of the yard. It's set to rotate through 90 degrees. That's your angle, that's theta. And project water out 53 feet. What is that? R. You're starting here and the water goes out a distance of 53 and it spins 90 degrees. So that's our theta. Okay, what is the area of the yard watered? So area is 1/2 R squared theta, but we have a problem. For any of the formulas, what has to be true about theta? Has to be in radians. So we know what 90 is, but if you had one you didn't know, remember you can just multiply by pi over 180 and get it. So that's pi over 2. So we have 1/2 times 53 squared times pi over 2. And so there's several ways you could write it. You could say 2,809 pi over 4, or 702.25 pi, or if you multiply out your pi, 2,206.18 square feet for the area.
Will you send one?
Yeah. And if I don't specify, I would accept any.
Okay.
Number 13. A wheel with a radius of 5 feet rotates 13 revolutions per minute. What is that? There's a couple ways you could do it. We can do it as an omega, 13 revolutions per minute. But what has to be true about omega? Has to be in radians. So we know that 1 revolution all the way around the circle is 2 pi radians. So this is 26 pi radians per minute. And we have to convert it before we can use it in the problem. Find the linear velocity, so we want v. So we can just do v equals r omega. we have not talked about and we need to?
Can we do like 7, 4, 8?
Sure. Let's do 8. So I told you the quadrant. We're in quadrant 2. Cotangent is -0.7395. So to move it to the other side, it has to be inverse, but we don't have a cotangent inverse. So first, what I have to do is think of this in terms of tangent. That means tangent is the reciprocal. When we put it in the calculator, we do the positive only to get our reference angle. So your reference angle is tangent inverse of 1 over 0.7395. And that gives us a reference angle of 53.5171. How do I put that in degrees? Or in quadrant 2, excuse me? And we get 126.4829 degrees. Is that okay? Anything else on those? So for tomorrow, let's try to do the next page front and back. So that's 14 through 27. We'll discuss that tomorrow, and then we'll finish it up.